Now that's how I like to go about completing the square, but there's an algebraic way to do this as well. So let's work on this same problem. Now in the algebraic way, you still have to get to a form that looks like y squared plus or minus a number times y equals some other number. So this here is going to be the algebraic way. Now, in order to tell you the algebraic way, let's make an observation over here about the geometric way. And what we did here essentially was we added to both sides this plus negative 5, 6 squared. And how did we get this negative 5, 6? Well, it was this minus 5/3 divided by 2. So we're going to do exactly that. We're going to add negative 5, 6 squared to both sides. Going back to the algebraic form here, in general what you do is you take this, in this case it's negative 5/3, you divide by 2, and you square it, and this will turn out to be, in this case, 25 over 36, and you'll take that and you'll add it to both sides. So this would be y squared minus 5/3 y plus 25 over 26 equals 2/3 plus 25 over 26. And of course, we did this computation earlier, that's 49 over 26, and somehow I managed to change my 36 to a 26. Let's go ahead and revert that. There we go, this looks better. So we take whatever's attached to the y, divide it by 2, square it, and add the resulting quantity to both sides. Now that we've done that, this next part can be a little bit more challenging than in the geometric process, or the geometric solution method. What will result every time you do that on the left-hand side is a perfect square. And what that means is that every single time the left-hand side will be able to be factored as y, and you take this and divide it by 2, so that would be 5, 6 minus 5, 6 squared. And of course that will be equal to 49 over 36. If you add the correct thing to both sides, this will happen every time. The left-hand side will be y minus, then whatever is attached to the y divided by 2, that's 5, 6 squared. And you could go ahead and check this. So let's take y minus 5, 6 squared. That would be y squared equals, or not equals, but minus 5, 6y minus 5, 6y plus 25 over 36. This, of course, these terms here, of course, being the inside and outside terms when you expand this as y minus 5, 6 times y minus 5, 6. And then negative 5, 6y minus 5, 6y, that would be, well, first let's copy the y squared term. Negative 5, 6 minus 5, 6 is 10, 6, which 10, 6 is the same. 10, 6 is the same as 5/3. So you see, we do actually get our left-hand side back. That is, this left-hand side is the same as this. And of course, you'll recognize this line as the same line that we got when we used the geometric way. This step is one of the reasons why I like doing the geometric way better. Sometimes it's difficult to see exactly how your expression factors. Another way, or another reason why I like the geometric method better, is I think it's just easier to remember. It's as long as you can remember how to make these shapes, these first and second shapes, then cutting in half and moving shapes around, I think, is easier than remembering to add this. Let's see if I can find it. This 25 over 36, which kind of seems a little bit random to me. Now you might say the other way it seems random as well. You can pick whichever method you'd like to do. I prefer the geometric way. Now, what you'll notice is that both ways, whichever way you choose to do, you always end up with an equation of this form here. Y minus something squared equals some other number. And that's the power of completing the square. That is why it works. This equation that I've boxed here is much easier to solve than the previous equation. You simply need to take square roots. So whichever way you choose, you'll always get to something that looks like this.